In HTML, the page scroll is handled by the browser and is based on the content of the page. With Three.js and React 3 Fiber, most of the time we have one canvas element taking the entire screen position, which makes it disconnected to the page scroll because of its fixed position. To establish a connection between our HTML page and our canvas, we need to listen to scroll event and update our 3D scene accordingly. That's exactly what scroll control does. It comes from React 3 Dry. As always, check the example and the documentation when you will want to go and dive deeper. But I prepared a simple 3D scene to discover how scroll controls work. Let's look at the HTML structure we have to render our page. Inside main.jsx, which is the entry point for React, we have document get element by ID root, and our app is rendered inside. So it's inside the root. If we go into index.html, we can see we have inside the body the root div. So inside that root, we have our app, and our app is this canvas, and then our 3D experience. To look how it reflects inside our browser, we have the root here. Then when we set a canvas, we have this div created automatically by React 3 Fiber. Inside, we also have a div taking the whole parent width and height, but it's full screen. And inside, we have the canvas. If we resize the window, the canvas width and height are updated automatically. Now to enable scroll into our 3D scene, we can use the scroll controls. We can use the prop pages to define how many pages we want. And one page is the total screen height. Now, if you look closely to the right, you can see that I can scroll, nothing is happening, but we have that scroll bar and it is the equivalent of 5 times the height of the screen. If we look closely to what it generated, it's next to the canvas, not inside, but just after. It created a new div with an absolute position, taking the full size of the screen, and inside a div that will make our container scroll. Let's see how to make 3D elements react to these scroll events. The simplest way is to go to our experience. We have all our food items displayed here. We can wrap them into a scroll component from Dry. It's a wrapper to tell this 3D element will react to the scroll, so their position will be affected. Now when we scroll, our food items are scrolling too. But the problem is, as soon as we reach the second page, we don't have items anymore. We will try to make one food item per page. To do it, let's go to the food item and change its Y position based on the page. Currently, the Y position is based on the page number, but we need to multiply it by the height screen. But because we are in 3D, we can't use the height of the screen in pixels. Instead, we will use the viewport. We can get it from user 3. And we'll get it from our state and get only the viewport. We are using the viewport because it is what is rendered on our screen and its size depends on your Windows size. Now, instead of just using the page, we can use minus viewport.height multiplied by the page number. Let's try it. On the first page, we have nothing. Then we have one food item per page. We have nothing on the first page because we are not starting from 0, but for 1 to have an introduction. Now we have 3D elements reacting to the scroll of the page. Let's try to combine it with the HTML elements. Create a new component named interface.jsx. Inside we will put our HTML, export const interface. We'll return different sections. We'll add for each of them a class name page so we can make them full width and full height of the screen. For the first page, it will act as an introduction, so we'll add a label telling welcome to Panda Sushi, scroll down, and add an icon to tell people they can scroll. Then on our other pages, class name page, we will render all our food items. So it's food items dot map. We'll get the food item and we'll render our page. We can move our page here, assign the key. We'll use the index of the food item. Key is equal to index and add the content. we'll just render the content of our food items, which are name and description. We wrap them into a food class. We add the title with food_title and the description within food description. Now our interface component is ready. Let's go to app. And next to experience, we will add our interface. But remember, we can't add HTML elements inside the canvas directly. We've seen that we can use the HTML component, but what we will need here to react to scroll is to use the scroll component, but we need to add the prop HTML to tell it that it is HTML content within. Now it should be fine. Let's add the CSS for our interface inside index.css. We have our page with the width and height to make it full screen. We display it to grid to position the content at the center. Then we have the introduction. We set a padding top to 1/4 of the viewport height. We have the label. We make it bigger. We center the text and increase the line height. Then we have our food items. We set the background. We make it like a glassy effect with the backdrop filter blur. We smoothen the angles. We add some padding and we define it width. But to make it responsive, we add a max width to 100% if the size of the screen is lower than 420 pixels. Let's see what we have so far. We have our introduction here. It's slightly pushed below to not conflict with the 3D. Then when we scroll, we have that nice glassy effect and we can see the 3D model behind. And we have it for each item, but we can see that it's perfectly aligned between the HTML element and the food item in 3D. But because our 3D elements are hidden behind the card, we will use the scroll to move the food item based on it to make a nice effect. We'll animate each food item independently. So let's go to it in experience. We have our food items here. To get info about the current scroll, we can use the useScroll hook. Let's declare scroll data is equal to useScroll. We will want to impact the food item position. So let's add a reference to its main group, name it ref, and let's declare it is equal to useRef. Inside dry documentation, you can see all the info we get from useScroll. So we have the offset, which is the current scroll position between 0 and 1, the delta, which is between the previous frame, and there are some useful functions like data range or curve to play with the scroll position and create nice effects. To update our reference position, we will do it in a use frame. And by default, we will set our position on the x-axis to 2. Then let's get the page scroll. It's equal to scroll data dot offset. We could use it directly just for a matter of demonstration. And we will affect the rotation of our food item on the y-axis. It will be equal to page scroll multiplied by math.py multiplied by 2. Let's try it. When we scroll, we can see our food items are also rotating. Now, instead of putting the position to 2 manually, we will try to make it slide based on the scroll position and the current displayed page. Let's remove it. And below, we'll put our logic. Let's get our number of pages. It will be equal to scroll data.pages, but we will remove 1 because we are starting from 0. And that way, here you can set the number of pages dynamically without having to change it everywhere if we wrote 5 directly. Then let's declare our offset x. We set it to 2. We saw it was a good position. Then we will impact our x position for our food item. We'll use scroll data dot range. Our range function works. You have a first parameter, which is the starting value between 0 and 1. And the second parameter is the end value between 0 and 1. And based on the current scroll position, we will have a new value between 0 and 1 between that interval. Because we want it to start to scroll when we are on the current page, we will use page minus 1 divided by the number of pages. And then we set the distance for that interval, so it's 1 divided by pages. So we have our number between 0 and 1. And we multiply it by the offset x. So we will always have a value between 0 and 2. Now we have that nice reveal effect when we start to scroll. Instead of using the range function, we can use the curve function to make the exposition smoothly go back to 0 when it reaches the end of the page. So we need to be on 2 pages instead of only 1. Now when we scroll, it appears, but when we scroll further, it disappears. But we don't have to restrict only to animate food items. We can add more dynamism to the scene by adjusting the camera position. Inside the experience, let's use a use frame function. We'll need also the scroll data here, equal to use scroll. To have access to the camera, we'll get the state from the callback function in the use frame, state.camera.position.x will be equal to -2 plus scroll data.offset multiplied by 4. So we'll start from -2 and we will have a value between 0 and 4. So our interval will be -2 to 2. Let's also affect our interface based on the scroll. So inside interface, we will fade out our introduction. So we need a reference to it. Introduction ref, const introduction ref is equal to use ref. We will need the scroll data is equal to use scroll. And we can do it because inside our app, we are inside the scroll controls, so it will work. Then use frame. We will change the opacity of our introduction ref. So current.style.opacity. It will be equal to 1 minus scroll data.range between 0, and we will make a small distance, so it quickly fades out. Now, if I scroll, I have the introduction smoothly fade out, and our camera is going from the left to the right, creating this nice effect in the background.